Welcome to How To for 3D Printing at Belleville Public Library. In this video, you will learn about the 3D printing process and how to prepare your object for printing at Belleville Public Library. First, what is 3D printing? 3D printing is a type of additive manufacturing in which material is laid down layer by layer to form a three-dimensional object. The most common type of 3D printing at the consumer level is called Fused Deposition Modeling, or FDM. This is the type of 3D printer the library has. FDM 3D printers use an extruder to melt plastic and lay it down onto a print platform. The extruder moves along the XY axis, and the build plate moves down the Z axis as each layer of the object is added. The library has a MakerBot Replicator Plus 3D printer. Our 3D printer prints MakerBot files. Instructions on how to prepare your design as a MakerBot file will be covered later in this video. The type of filament material we use at BPL is polylactic acid, better known as PLA. PLA is a bioplastic derived from corn and other sources of starch. PLA could be lightly sanded and painted with acrylic paints, making it ideal for a range of applications from hobby figurines to jewelry to replacement parts to prototypes. The 3D printing process. The 3D printing process in a nutshell has 3 steps. 1. Obtain a 3D object file. 2. Use slicing software to prepare your object file for printing. In this step, you will specify different print settings, then export your design into a MakerBot file for a 3D printer. 3. Print. Send us your MakerBot file and the library will transfer the file onto a USB stick and load it into our printer. Let's break down these steps. Step 1. Obtain a 3D object file. First, you need a 3D object file, usually a file type .stl or .obj. You have some options. First, you can download a 3D object model. There are thousands of object files you can download from websites like Thingiverse. Make sure to check the object's description for tips on print settings from the creator, as well as comments from people who have printed the file. Also, please note the license the creator has assigned to the object. Most objects are freely available under Creative Commons, sometimes with restrictions like no commercial use or no remixing the object file. Make sure to always give appropriate credit to the creator. A second option is to design your own object using computer-aided design software, or CAD. There are plenty of CAD options out there, from expensive industrial grade to free open source. Tinkercad is a great free and beginner-friendly option. You can use it in your web browser. I highly recommend taking the time to complete the beginner lessons on Tinkercad before you start your design. Whichever software you use, export your 3D file as a printable file, usually .stl or .obj. Step 2. Slicing software. Once you have your 3D object file, usually a .stl or .obj file, you will need to import it into MakerBot CloudPrint slicing software to prepare the file for printing. Called slicing software because it slices your digital 3D model into many horizontal layers. MakerBot CloudPrint slicing software will turn your 3D model into a .maker file our 3D printer can read. This file gives the 3D printer exact instructions on the path the extruder will take to lay down each layer of the object. In MakerBot CloudPrint, you will need to specify print settings like orientation, support structures if needed, layer height, and infill. The following are print settings you may wish to modify. Support structures. Structures are needed for any overhangs of your object. The 3D printer must print onto previous layers. It cannot print into air. By default, supports are turned on in MakerBot CloudPrint, and the software will add them automatically to any overhang greater than 68 degrees. Supports are easily removed from the object after the print is finished. Sometimes you can orient your object on the build plate to reduce or avoid the need for supports, and therefore reduce filament and print time. For example, in this image, if the T was lying flat on the bed plate, supports would not be necessary. Rafts. A raft is a layer laid down at the beginning of printing. A raft provides an even, flat foundation for your object to be printed on, and it helps with adhesion to the build plate. Like supports, rafts are easily removed after the print is finished. Rafts are also turned on by default in MakerBot Print. If you decide not to print with a raft, you risk warping and curling. Layer height. Changing the height of the layers in your object will change the surface quality of your print. Thicker layers mean lower resolution, a rougher surface quality, but a faster print time. Thinner layers make for higher resolution prints with smoother surface quality but a longer print time. MakerBot suggests their standard print quality, which is 0.2 millimeters, about the thickness of 2 sheets of paper. Shells. Shells are the outer walls of your object. 2 to 5 shells is enough for most prints. You may consider adding a few more shells if you plan on sanding your object after printing, or if you want to increase the print's strength. Adding shells will increase filament use and print time. Infill. Infill is the internal structure of your object. An infill of 0% will make your object hollow, while a higher infill percentage will make your object more solid. For most objects, 10 to 20% is adequate. Note that a higher infill percentage means your object will require more filament and will take longer to print. Do a quick demo with MakerBot CloudPrint. First, you need a MakerBot account. On the MakerBot website, follow the prompts to create a free MakerBot account. Once signed in on MakerBot CloudPrint, get started by selecting the Start a New Print option on the left side menu. First, make sure to set the printer to Replicator Plus and ensure the filament is PLA with Smart Extruder Plus. Import your object file, usually an STL or OBJ, by selecting Add Models, then Add Files, then select the file from your computer. Here's an object I designed in Tinkercad. Use the options in the bottom left to change the view screens. Use the options in the top left to move your object around the build plate, rotate your object, or resize your object. You can also move your object around the build plate by selecting it and dragging it. Let's look at the print settings on the right side of the screen. You'll notice the print settings are set to the default setting called Balanced, with a layer height of 0.2 millimeters, an infill density of 10%, and 2 shells. You can keep this or you can customize the settings. For more settings, use the drop-down menu. Be sure to hover your cursor over the setting for more information. Once you are happy with the settings, select Print Preview. MakerBot will now slice your object and generate the print file. This is also when any supports will be added if your object requires them. Toggle to 3D to see an estimate of print time and filament needed. If you'd like to make modifications, select Exit Print Preview, make your modifications, and select Print Preview again. Belleville Public Library will not print objects with an estimated print time greater than 3 hours. To reduce print time, consider making your object smaller, decreasing infill percentage, or separating your object into multiple components and printing over multiple sessions. Once you are satisfied with your file, export as a MakerBot file. Step 3. To submit your 3D model for printing, upload your MakerBot file to a 3D printing request form on our website. Staff will print your object, then contact you to arrange payment and pickup. Belleville Public Library has some 3D printing guidelines. First, your object must fit within the build area and may not exceed 3 hours in print time. You may not print weapons, weapon components, keys, or sexually explicit objects. To review, there are 3 main steps for 3D printing at Belleville Public Library. Step 1. Download a 3D object from an online website such as Thingiverse, or design your own object using a CAD program such as Tinkercad. Step 2. Prepare your file for printing and customize print settings using MakerBot CloudPrint slicing software. Step 3. Send us your MakerBot file through the form on our website and we'll print it. Your 3D object might need some post-print processing. For more information about sanding, gluing, priming, and painting, visit MakerBot.com. Thank you for watching Belleville Public Library's how-to for 3D printing. Visit our website for more details about 3D printing at Belleville Public Library. Also visit MakerBot.com for great support resources for preparing objects in MakerBot CloudPrint.